There are two types of cellular respiration. Anaerobic occurs only when in desperation. Aerobic's more efficient, making 38 ATP. Anaerobic barely makes 5-3. Aerobic can make this energy through glycolysis. Krebs and the ETC. Glycolysis up first in either process. It might be hard to get, try not to get nauseous. Enzymes convert glucose to glucose 6-phosphate. 2 ATP are used to power this change. It then splits into 2,3 carbon sugar phosphate. Enzymes catalyze and rearrange it to 2 pyruvates. NAD plus reduces to NADH on top of this. Pyruvic acid and 2 ATP are the products of glycolysis. This all comes from a molecule of glucose. If you think we're done, we aren't even close. Cellular respiration, if it's anaerobic or aerobic, it makes breathing seem epic. Cellular respiration, if it's anaerobic or aerobic, it makes breathing feel epic. What happens next depends on oxygen. If not enough, it'll go anaerobic then. NADH and pyruvate convert to NAD plus and lactate, reversing the oxidation that made pyruvate. NAD plus goes back through step 1, making some ATP till oxygen isn't none. That is known as lactic acid fermentation. It is one route to ATP formation, although if oxygen was present. Krebs is where pyruvate get sent. The first step involves the pyruvate. CO2 is released, making it acetate. This all happens in the mitochondrial matrix. Get ready for some details, don't forget the basics. Resulting from the first step, NAD plus gets reduced. One molecule of NADH is produced, plus coenzyme A binds to the acetate. Acetyl-CoA is what it will create. It delivers acetate to the start of the Krebs cycle. Clearly, coenzyme A is somewhat vital. Acetyl-CoA combines with oxaloacetate. Small process forms a 6-carbon acid citrate. Coenzyme A then detaches. I spit so much fire I don't need to light matches. Citrate is rearranged in this process several times. I'm number 1 in the game, you can't top my rhymes. Some NADH is made plus FADH2. 1 ATP is formed, I know it's but a few. The cycle flows twice, 2 times per glucose. The ETC is next, that's just how it goes. Cellular respiration, if it's anaerobic or aerobic, it makes breathing seem epic. Cellular respiration, if it's anaerobic or aerobic, it makes breathing feel epic. The electron transport chain goes down to mitochondria, the inner membrane. NADH and FADH2 carry hydrogen atoms to the system. True hydrogen atoms then get separated into protons and electrons. You're all most fully educated. Proteins move electrons through the system step by step. Soon 34 ATP will be made. This is just prep. At each electron transfer, some energy is released. Proton concentration of inner membrane space increased. The proton distribution becomes unstable. They diffuse back into the matrix. Through this, they are able to pass through ATP synthase, combining ADP with the phosphate. Each FADH2 creates 2 ATP, but NADH forms only 3. Oxygen accepts an electron less. This process is done. Wasn't that fast? 1 molecule of glucose makes ATP 34. Respiration's now complete, there is no more. Animals respirate and plants do too. Sorry for saying that so late, I thought you already knew. This is where my rap song ends. Now you know respiration, go tell your friends.